Welcome to World Decoder. Today we explore the fascinating engine behind artificial intelligence and its ability to generate stunning imagery. Have you ever wondered how a few simple words typed into a computer can instantly conjure a breathtaking digital masterpiece? It seems like pure magic, but beneath the surface lies a complex symphony of mathematics, data, and massive computational power. While a human artist uses intuition and experience, the AI relies on a vast library of learned patterns and probabilities. Modern image generation systems are trained on billions of image and text pairs, creating a massive database of visual associations. During this intense training process, the model meticulously learns how specific words correlate with distinct visual shapes and color palettes. For example, it learns that the word girl is usually associated with a specific body shape and human facial features. It understands that white out dye implies a specific long dress style, silk material, and a distinct cultural fashion aesthetic. When it sees the word sunset, it instantly retrieves the corresponding gradients of warm light, deep oranges, and soft purples. The term cinematic style teaches the model about high contrast, shallow depth of field, and dramatic lighting techniques used in film. However, the machine does not truly understand these concepts like a human. It only recognizes statistical correlations between the data. It creates a map of probability, predicting which pixels should likely appear together when certain keywords are present in the prompt. Now let us look at the technical mechanism. Most modern systems utilize what is known as a diffusion model architecture. The process begins with pure random noise, a canvas of digital static that contains absolutely no meaningful visual information yet. Based on your descriptive prompt, the model predicts how to gradually clean this noise, step by step, removing the chaos. Through many iterative cycles, the meaningless noise is transformed into a coherent image that matches the description you provided earlier. This is the core magic of diffusion, reversing the destruction of data to reconstruct a brand new, pristine image from nothing. Your text prompt is actually converted into numerical vectors, mapping your words into a vast, multi-dimensional space of meaning. These vectors act as a precise guide, directing the noise reduction process to sculpt the image exactly as you intended. But why does a simple sentence of just a few words yield such a rich and detailed visual result today? This is because the model has already learned the fundamental structures of characters, lighting, composition, and various artistic styles beforehand. When you write ancient warrior in the desert, the AI accesses millions of similar examples stored in its weighted memory. It does not need to be told how to draw sand or armor, it simply retrieves those features from memory. The model fills in the missing details based on optimal probability, ensuring the lighting and texture look natural and correct. This leads us to an important question. Why does adding more detail to your description produce a much better result? Every word you add acts as a filter, narrowing down the vast probability space and reducing the noise of interpretation. If you just type the word girl, the probability space is too wide, leading to a generic or random output. But by specifying 20 years old, black hair, and white dress, you significantly constrain the model to a specific target. Adding environmental details like rain and backlighting further refines the composition, leaving very little room for the AI to guess. The result is a highly accurate image because the mathematical vector has been guided to a very precise location in space. This brings us to the final philosophical debate. Does artificial intelligence actually have an imagination like a human being does? The answer is no, not in the human sense. AI lacks consciousness, internal visualization, and the spark of true intent. It does not dream or feel. It simply executes massive probability calculations based on the data it has been fed. However, the volume of data and computing power is so immense that the result often mimics the appearance of creativity. It can combine concepts that have never met, like Van Gogh and cyberpunk, creating something that looks uniquely new to us. The output can be so sophisticated and aesthetically pleasing that it evokes real emotions, blurring the line between calculation and art. So from a simple text prompt to a finished image, we witness a journey through data, vectors, and noise reduction. As these models continue to evolve, the boundary between human instruction and machine execution will become even more seamless. We are entering an era where our words can instantly shape our visual reality, unlocking endless possibilities for digital creation. Understanding these mechanisms helps us appreciate the tool not as magic, but as a triumph of human engineering and math. From hyper-realistic portraits to abstract dreamscapes, the versatility of diffusion models is reshaping how we create and consume visual media. The machine sees the world as a vast collection of patterns and weights, a perspective entirely different from our own experience. These weighted memories allow the system to recall the essence of an object without needing to store every single pixel. It reconstructs the idea of a cat pixel by pixel, guided by the statistical likelihood of where fur should be. What takes a human hours of manual labor can now be synthesized in seconds, democratizing access to high-quality visual expression. This iterative process allows creators to explore their imagination rapidly, refining their vision through a dialogue with the machine. The search for the optimal image is a mathematical journey through a high-dimensional space that our brains cannot fully visualize. The level of detail achieved is a testament to the sheer scale of the datasets used to train these models. Reducing noise is akin to a sculptor chipping away at a block of marble to reveal the statue hidden inside. The model understands the relationship between these words, knowing that a ship belongs on the ocean, not in the sky. It applies physics-like logic, not because it knows physics, but because it has seen millions of images of water behaving. Artists are now using these tools to expand their capabilities, using AI as a collaborator rather than a replacement. We are moving beyond static images, as these same principles are now being applied to generate video and 3D environments. The collective visual heritage of humanity has been compressed into these models, available to anyone with a keyboard and imagination. However, we must remember that the model also learns biases present in the data, reflecting our own societal stereotypes back. It requires human guidance and critical thinking to steer the AI away from generic outputs and towards truly unique creations. Creativity is no longer just about manual skill. It is about the ability to curate, describe, and direct the machine. This technology empowers storytellers who may not have drawing skills to finally visualize the worlds living inside their heads. We are witnessing the birth of a new art form, one that challenges our traditional definitions of authorship and effort. Remember, every beautiful image you see starts as nothing but random chaos, organized into beauty by mathematical probability and vectors. The vectors are the invisible hands that sculpt the digital clay, guided by the semantic map of human language. Mastering this technology means mastering language. The better you can describe your vision, the better the AI can build it. The gap between thought and visualization has never been smaller, shrinking to the time it takes to type a sentence. The latent space of these models is like a vast universe, containing infinite potential images waiting to be discovered by you. You can travel from the planet of oil painting to the world of photorealism in a single second of computation. It is a partnership. The AI provides the technical skill and the database, while the human provides the intent and soul. Tools like Midjourney, Stable Diffusion, and DALL-E are just the beginning of this revolution in synthetic media and content creation. Soon, this capability will be integrated into every piece of software we use, becoming as common as a spell checker. It will help us visualize ideas faster, communicate concepts clearer, and unlock the creative potential inside every single person. We have seen how noise becomes art, how words become vectors, and how data becomes a new form of reality. We encourage you to try these tools yourself. Explore the latent space and see what wonders you can bring to light. The code is written, the model is trained, and the infinite canvas is ready for your input. What will you create? This has been a deep dive into the mechanics of AI image generation, decoding the complex world of pixels and probability. If you found this explanation valuable, please like the video and share it with others who are curious about AI. Thank you for watching World Decoder. Subscribe to our channel to uncover more secrets of the digital universe. See you soon!